All right, analysts, we have looked at the strings that are sitting inside of the binary. We have used a tool called floss in order to extract them. And in order to look at the structure of the binary and maybe find some more information about when it was compiled and what kinds of functions it might be using, we're going to go to this Flare directory right here, which is a shortcut to the programs directory. And we're going to scroll all the way down, so go all the way from the top and find this utilities subdirectory right here. We open up the utilities subdirectory and we're going to scroll a little bit of the way down and we find these PE programs right here. We want to open up PE view. So double click and open up PE view. And when this opens up, it will ask you, what do you want to load into it? And it will try to find an executable as a default. Now, we don't have our malware sample in executable format, so we can go to all files. And what we want to do is find our malware.unknown.exe.mouse, double click that and load it in. Now, what I want to point out is that this right here in the center is kind of a very interesting way to think about what a PE looks like. Now, you think like with a PowerShell script or maybe a text file, you kind of know what it looks like when you open it up, right? You see some characters and maybe some sentences and maybe some if it's PowerShell, maybe you see some functions in there. But can you honestly say, what does a portable executable look like? Like really, when you think about it, what does it really look like? Well, when you open it up in something like PE view, you get an idea of what these things are actually made of. And what it comes down to is that a portable executable is really nothing more than a gigantic array of bytes. And you see these bytes are represented here in hexadecimal format. And you'll see the raw data are the hexadecimal bytes in the center. You see the P file column right here represents the offset of these bytes. So where in relation to the beginning of the program did these bytes exist? And all the way over here on the right side, you'll see the value column. It's a character representation of what these bytes look like. Sometimes they are actual characters and sometimes they're not able to be represented. And that's when you see these dots right here. But truth be told, all of these bytes have some kind of purpose inside of the binary. Now, every portable executable follows the same exact format. It starts with this byte right here, which tells the file system and the operating system what kind of file it is. This MZ right here is a signature giveaway that this is a Windows portable executable. And this is actually someone's initials. I actually learned that recently. And so following this magic byte right here that tells us that this is an executable, a little ways down from this, we can actually pick out a sentence right here. This program cannot be run in DOS mode. This is the DOS header of the portable executable. Now, I'm not going to go through the whole anatomy of a PE. That's kind of outside of the scope of this course. But what I want to get across is that all of these programs follow a very, very particular format. And so something like PE view was constructed to tear apart this format and look at all of the different sections, and we can extract a lot of insight as to what this executable might be doing from looking at these sections. Now, one of the first things that I like to look at is to go right down here to the image file header, which is under the image NT headers section. And so one set of bytes inside of the portable executable will have the time date stamp. The time date stamp is a time of compilation for this particular executable. Now, the time date stamp may in fact be a reliable point of information, but it might not. There are some circumstances in which this time date stamp is going to be the same no matter when this executable was actually compiled. Now, for this one, I did happen to compile this today. You see the calendar down here is 9/4/2021. And you can see up here that this was compiled on 9/4/2021. So the date timestamp of this executable is accurate. But let's say, what if this said 1992, some date in 1992? That's pretty old, right? It's not necessary that that particular executable was compiled back then, but that might be an indicator of some other kind of information. The Borland Delphi compiler, so malware written in Delphi, if it was compiled with the Borland Delphi compiler, it will always have a timestamp of 1992, a date in 1992. And so this can be a reliable piece of information, but you really need to look at it carefully and critically to determine if that was actually when it was compiled. So let's move on from the date timestamp down to the image section header of the .text section. So the .text section is one of the about 5 locations in the binary that has information that can be read into the binary at runtime. So one thing that I like to look at here are the virtual size and the size of the raw data. You can compare these values. These are going to be written in hexadecimal. And so what you can do is break out your trusty programming calculator. And you want to take a look at the virtual size and the size of the raw data for both of these fields. Now, if we select the hex section of our programming calculator and we type in the size of the raw data, 1600, in decimal, that means that that is about 5,632 bytes. Now, we take that number and we compare it to the virtual size here, 15A1. So let's go ahead and go back to our programming calculator and 15A1. And it looks like that is 5,537. Now, if these two values are similar, we can ascertain that the size of the raw data of the binary is roughly the same as the virtual size. You can think of the virtual size like the amount of data on disk when the binary is run. Now, let's say that this was much, much higher than the size of the raw data. So the actual raw bytes inside of the binary are actually much, much lower than what it is when it's run. And what we could maybe surmise from that is that there is more to this binary than is initially available to us. And we can maybe think that that's what's known as a packed binary. So I do like to look at these, take a note of these, and make sure that these values are relatively close. If they're not, we may be dealing with a packed binary. And a little bit later in the course, I'm going to show you exactly what that looks like. Now, I want to look at one final piece in PE view. And if we go to the section of the R data and look at the import address table, this might be one of the most important parts that we can see inside of PE view. Now, to really understand why the import address table, or IAT, is so important, we need to look at something called the Win32, or really now just the Windows API. Now, to explain the Windows API, I think I'm going to break this into its own video because it's a very interesting topic, but it can be a lot at first glance. So I want to make sure that we break it down. So meet me in the next video. We'll briefly cover what the Windows API is, and then we'll go back to why the import address table is so important for this phase of malware analysis. So meet me in the next video.